In this video we look at the FP2 work on integration. The specification emphasises the fact that we need to be able to use partial fractions in our integration. We need to understand the basic properties of the definite integral, and two important cases of integration involving the inverse trig functions, that the integral of 1 over root a squared minus x squared and the integral of 1 over a squared plus x squared. So the key results that we need are the two inverse trig results, and we must remember that if it's a definite integral that we are using radians for the angle measurement. We must be able to use partial fractions, and the work on partial fractions has been looked at in an earlier video in this series and is not considered in this video. Finally, we need to understand that if we've got f of x is the integral between a and x of f of u du, then the derivative of capital F is simply little f. And all that's saying is basically that integration and differentiation are reverse processes of each other. So let's rapidly move on and have a look at a couple of examples. First one coming from the 2012 paper, and we have to integrate between 0 and 1 over e to the x plus 4e to the minus x. So there we are, 1 over e to the x plus 4 lots of e to the minus x. Well, e to the minus x is just the same thing as 1 over e to the x. So we can rewrite the original integral as the integral between 0 and 1 of 1 over e to the x plus 4 over e to the x. Multiply the top and bottom of the fraction by e to the x, gives us something simpler to work with. So we've got the integral between 0 and 1 of e to the x over e to the x squared add 4. Now it's been suggested that we should use the substitution u equals e to the x. So if we've got u equals e to the x, then du by dx is e to the x. In other words, du is the same thing as e to the x dx. So if we now just move the e to the x there to put it together with the dx term, we've got e to the x dx there, and we've got 1 over e to the x squared plus 4 at that point. The e to the x dx just becomes our du. 1 over e to the x squared plus 4 becomes 1 over u squared plus 4. So we've got the integral of 1 over u squared plus 4 du, but we haven't yet dealt with the limits. So when x is 0, u is going to be e to the 0, and e to the 0 is 1. When x is 1, u becomes e to the 1, which is just e, so that the upper limit is e. So once we've done the substitution, we've obtained the integral between 1 and e of 1 over u squared plus 4. This is a standard integral, so we can say that that is going to be a half tan to the minus 1 of u over 2 between 1 and e. Remembering that we must be in radian mode on our calculator, we can then evaluate that and obtain the answer of 0.236. So the marking of this, there were 4 marks for taking the original integral and obtaining the integral 1 to e of 1 over u squared plus 4 du, and then 2 answer marks for evaluating that integral. Our second example is a very short one coming from the 2011 paper, which is worth just 3 marks. So for the first part of the question, we have got f of x is equal to the integral between 0 and x of sine e to the t dt. So, remembering that differentiation just undoes integration results, we basically at this stage have f dash x must be sine e to the x. Moving on to part B, let us define g of x to be the integral between 0 and x squared of sine e to the t dt. Now the only difference between g of x and f of x is simply that the limit has changed. So we can say that g of x is the same thing as f of x squared. Or in other words, we could say that g of x is the same thing as f of u, where u equals x squared. So to find the derivative of g with respect to x, we want the derivative of f of u with respect to x, which is there, and the chain rule tells us that that is the same thing as the derivative with respect to u of f of u times by du by dx. Now we know the derivative of f can be written as f dash u. We know that the derivative of x squared is 2x. We know that f dash x is sine e to the x, so f dash u is going to be sine of e to the u times by 2x, but u of course is just x squared, so we've got the derivative of g is 2x sine of e to the x squared. Marking on this question, well really part A is just 1 mark for writing the answer down, part B is for method mark for realising that this integral here is just f of x squared, and then making use of the chain rule to obtain the final answer for those 2 marks.